Now what we are going to do here is we'll solve one problem. Okay, most probably I'll be solving problem by midpoint method or the improved Euler's method. Okay, and I'll not be solving problems on Hume's method because this kind of problems we are going to see in the next lecture, that is on multi-step methods. Okay, so we are still discussing single step. So this is one improvement and this is another improvement. So let us solve one problem. So again we'll solve the problem that we solved in the previous lecture. What was the problem? The problem was this, let's say y dash is equal to y t square minus of 1.1 y. So we have to solve this differential equation, and again if you go back and see, they gave us the initial condition. And what was the initial condition? y0 is equal to 1, y at x is equal to 0 is equal to 1, and the step size for, so what we are doing, we are solving this problem using midpoint method, and step size we are using as 0.5 and 0.25. We will use both the step methods, both the steps, sorry, and the domain was 0 to 2. Okay, so this is the problem that we are going to solve by using midpoint method. I'll solve for h is equal to 0.5. So once you understand for h is equal to 0.5, you can extend it to 0.5, and I'll also show you the plot how the solution to this differential equation looks like when we solve it by the midpoint method. Okay, so before solving, let us write down the actual equation. So the actual equation is half yi plus half. So one thing that you need to understand here is, to get xi plus half, what you are going to do is you are going to add h by 2. So that is xi plus half is nothing but xi plus h divided by 2. So these are the two formulas that we are going to use. Again, I am going to follow the table method. So if you see the formula, you'll understand what is our requirement. Okay, so first of all, let us talk about h. So h again is 0.5 and h by 2 is going to be 0.25. So yes, but now in this problem your independent variable is t. So in place of x, what we can do is we can write down t. So the first column is going to be ti. Okay, then the next column is going to be my yi. Then what we need here is ti yi. Okay, and then when you multiply it by h by 2, so basically if you see, the main formula is this: we want ti plus half, yi plus half, and to get yi plus half, what you're going to do, you're going to use this formula. So if you see this formula, you'll understand what should be in the table. Okay, so next is going to be yi plus half. Then the next point is going to be ti plus half, and then plus half yi plus half. And then when you substitute everything, this in this equation, you will get the final answer is 1 plus 1. So based on the formula, you'll realize what is the requirement of our table. So let us write down the first from 0 to 2. So this is going to be 0. The next point, what you're going to do, you're going to add 0.5, that is h. So this is going to be 0.5, this is going to be 1, this is going to be 1.5, this is going to be 2. Now we know from the boundary condition or the initial condition that at x is equal to 0, what is the value of y? 1. So that means what we can do, we can write down 1 here. Now let us calculate f ti yi. So based on this, we know that f x of ti yi, this function is nothing but what? Y into t square minus 1.1. So these are the two formulas that we are going to rely on to complete this table. So what you're going to do now, you're going to substitute the value of 0 and 1 in this equation. So if you substitute that, now I won't actually substitute, I hope you guys know how to do this. You'll find out the value of f that you're getting is minus 1.1. Okay. Now if you see this, the next thing that you need to calculate is yi plus half. So to calculate yi plus half, what you're going to do, you're going to use this equation. And if you see, we already have everything. We have fti yi, we have yi. So and also h by 2 is going to be 0.25. So if you substitute all the values in that equation, the answer that you will be getting is 0.725. Okay. Now let us talk about ti plus half. So what is ti plus half? So ti plus half is nothing but what? Ti plus h by 2. So what is ti? Ti is 0. And what is h by 2? 0.25. So 0 plus 0.25 comes out to be 0.25. Now the next thing, so main focus here is to calculate this. Okay, once you calculate this, and to calculate this we need this and this, and to calculate this we need this and this. So this is how it goes. Now the next thing, what you're going to do, you're going to substitute the value of yi plus half and ti plus half in this equation. Okay. So once you substitute these values of 0.725 and 0.25 in that equation, the value that you are getting is minus 0.752. Okay. Now we know the value of f ti plus half, y ti plus half, and we know the value of yi. So once you substitute this and this in this equation and multiply by h, you'll find out the value 0.62391. So 0.62391 becomes your yi for the next iteration. 0.6. Okay. Now again follow the same procedure and substitute this ti yi in this equation, and you'll find out the value that you're getting is 0.53032. Now substitute this in this equation, and you'll find out the value of y half that you're getting is 0.49133. And now ti plus half is nothing but ti plus h by 2. Now what is ti? Ti is 0.5 plus h by 2. H by 2 is 0.25. 0.5 plus 0.25 comes out to be 0.75. Again substitute this value in this equation, and you'll get the value 0.264089, and substitute this in the main equation, you get the value 0.491865. and if you go on doing it, I'll just complete the table here. So this is the value that we'll write down here, and this completes our calculation. So what we need is this column, and I think we have completed this. So similarly, what you can do the calculation for h is equal to 0.25. So again, you can form a table and you can calculate for h is equal to 2.5. So if you do that, and once you do that and once you plot it, you will find out that this is the graph that you'll be getting, and we were getting similar kind of graph. So if you see the dotted line which is underneath this, okay, you cannot see it, that is your analytical value, okay, and this rectangle, the hollow rectangle, is your h is equal to 0.5, and the solid rectangle, the filled rectangle, is 0.25. So you can see how well it matches the analytical value, okay. And similarly, if you can see the previous graph that we had, that is this graph. So this was the graph where this was your analytical value, okay, and this was your Euler's method, and this also was your Euler method for 0.5, and this was for 0.25. So if you can see by midpoint method how improved solution you're getting, which is very important for us to understand, okay. So the solution that you're getting is now improved. So this is your midpoint or improved Euler's method, okay.